We're going to answer this question before us. It says, consider this function here. And as you can see, it's a piecewise function. We need to sketch the function on the axis below, label with coordinates, axial intercepts, and endpoints. Now, we have our CAS with us, so we should be using it efficiently to help us with drawing this thing. So what I'm going to begin by doing is going f of x, and I'm going to define this piecewise function. In order to get up these three options here, you want to click this button again, and you've got that right there. So I've got 3. So now I'm just going to go 4 plus x, and then this will be x. Control this is less than or equal to 1. So I'm putting in those domains as well. This is just 3, which means it's just a horizontal line with 1. Control this is less than x. Control this is less than 5. And then this one here will be x minus 2. And then here I'm going to get 5. Control this is less than or equal to x. Control this is less than 9. Having done all that, I hit enter, and now it's defined. I can now come to the graph portion, and I can give this a sketch by simply typing in f of x, and as you can see, that f is bold because it has been defined. And now I have this pretty thing before me. Now, what we need to do is figure out where all these endpoints are in order to help us out. So if I go menu, and if I go analyze, and I go maximum, we can figure out what the maximum will be. It will be 9, 7. And then you might be asking yourself, well, how can I figure out the endpoints here, here, and here? These look a bit tricky. Well, what if we went analyze maximum to get this one for us? There we go. That's going to be 1, 5. And then here, this is clearly going to be an x-intercept. So we can just go 0 and we can get, whoops, we can get that one for us. And now to get these ones, we'll probably use the trace function. So let's go trace and graph trace. Now, I know that it is beginning at 1, isn't it? It's from 1 to 5. It's from 1 to 5 there. So if you just type in 1, then enter, oh, and then what you might need to do is simply just go up, across. There we go. Now that is, oh, it's not giving it to me exactly. It's giving me 1.3. And this is probably where we're being a bit too pedantic, because we know that if this is, if this line here is just y is equal to 3, it's a horizontal line, well, this point is just going to be 1, 3. And this point over here is just going to be 1, 5. So, sorry, 5, 3. So 5, 3 will be there. So you wouldn't type in 1, enter, cross. You wouldn't put it in 1.3 because obviously it just hasn't got there exactly. If I just go back a little bit, oh, it just keeps jumping over for some reason. But we know it's going to be 1, 3. And that's where you got to use a little bit of common sense sometimes. Just don't blindly follow your CAS. Think it through. All right, so let's now draw everything in. And there's one more thing I need to put in, and that is what's happening when x is equal to 0, because I've got another x-intercept there. So let's go when x is equal to 0. That's going to be 0, 4. So that point there is going to be 0, 4. All right, having said all that, let's get to sketching now. All right, so we also need to just kind of appreciate what each of these sections are here. So this here is clearly my 4 plus x. All right, so this part here is my 4 plus x. So it's going to be, if I can draw here, there we go. It's going to be there, and I'm stopping here. I'm going to have this point right here, which is 0, 4, and this point here, which is negative 4, 0. Then this endpoint here is 1, 5, 1, 5. And remember, you have to have a closed circle there because it is less than or equal to 1. So it's because it's less than or equal to, it's a closed circle. Then I have from 1 to 5 for 3. So I'm going from here to here. This point here would be 1, 3. And this point here would be 5, 3. 5, 3. And then, as you can see, the next point is actually connected to it. And as you can see here, do you see for this one right here, 5 is included. So that means I'm actually going to include this point. And then it's just going to go up and stop here. It's going to be an open circle there because it's not including 9. And this point here is 9, 7. We could have figured that out ourselves. We could just chuck 9 into the Xbot to get there. And just like that, we're done. We've labeled all the x-intercepts. We've put everything in. We've used our CAS efficiently to answer this question. And that's it. That's all we had to do there. All right, next, state the domain and range. All right, so what is the domain of this thing going to be? So remember, the domain is all the x values. And as you can see, it's going from negative infinity and it's including everything all the way up to 9. So it's going to be from negative infinity to 9, but you're not including 9 because you've got an open circle there. And then we continue on. Now we're going to figure out what the range is going to be. So the range. Now the range, see how this one's going all the way down? So that means I'm going all the way down to negative infinity for the range. And where do I stop? Well, I'm going to stop at, this is my highest y value. That's going to be 7. So it's going to be 7, but we're not including that either because of that. Then the next thing we have to do is, for this part, find the values of x for which f of x is equal to 3.5, correct to 1 decimal places. So take a note, it's saying correct to 1 decimal place. That means we're going to have to use our CAS to do this. Now, 3.5, if we come look over here for a second, what we might want to do, and this is probably the best way to go about it, if you just hit tab and we just draw in where 3.5 is, you can see that it exists at 2 points here, there and there. Now, if you wanted to, I think this would be the slow way of doing it. You could go menu, analyze, intersection, and figure out the intersection from there to there. And there's one answer. Then menu, analyze, intersection from there to there. And there's your other answer. That's one way to do it. So as you can see, just by looking off this, that means we're going to get x is equal to negative 0.5 and 5.5. So if I come over here now, I can say x is equal to negative, and also take note, it's 2 marks. So let's just put in exactly what we're doing here. We're going f of x is equal to 3.5, and we're solving it for x. So this is where you got to be careful. Oh, sorry, not 3.5, solving it for x. I'm looking at the marks and I'm saying, all right, how much working should I put here? Let's put a bit of working here. Then I'm going to go x is equal to negative 0.5, or x is going to be equal to the other one being 5.5. Now, we've done this graphically. The other way you could do this is you could come over here and go menu, algebra. We could go solve, and then we could type in, all right, f of x when we're equal to 3.5 for the x values is going to be negative 0.5 or 5.5. So once again, that's how you would do it. So that is how you would draw a piecewise function, utilizing your CAS and making sure you can recognize the domain and range. Make sure you're looking at the mark schemes as you're going to ensure that you're doing everything correctly and just reading things carefully. A big thing that people make mistakes on is not reading when they ask to give things in terms of decimal places. So if it says 1 decimal place, make sure you do give it to 1 decimal place. And that is how you would approach a piecewise question. Hopefully you found this helpful.